Okay, first, I would like to talk about how do I create a water pumping system. So first, I obviously go into the TIA portal. I'm using a TIA portal version 16, and this is the create new project. So this way it will be created. So I would like to name my project water pumping system. Okay, so now I'll create. Okay, so after you create your new project, now first I would like to start with configuring a device because we need to know what sort of devices are we using, because what sort of CPU are we going to use. So I'll click configure a device, and then I'll add a new device. Okay, now as you can see, there are like a lot of controller, PC system, and HMI, the human machine interface. So now we just have to use a controller for our water pumping system project. So for this project I'll use a S7 1500 series. So I'll pick a 1513, which I think it should be enough. So as you can see here, this is like something like the CPU serial code. So for our simulation, we can just pick anything, but for an actual for the actual usage, you have to make sure that it's the right article number, the right serial number, and the right version, so that it is compatible. So I'll just pick this, and I'll add it. Okay, now, all right. As you can see here, we have our CPU right here and a rail. So this is like the hardware view of our system. So as you can know, this is here you can see the catalogs. This catalog where we can add something like the power supply or another CPU or the digital input, and then DI is digital input, DQ is digital output, and many other stuff like analog input and stuff. So these are the other modules that you can add to the system according to what we need. So this is our device view. You can see there's like topology view and network view, but we only need to use the device view since they already provided the rack. This is like a rack where we can add whatever we need it. So there's a lot of rack, we can expand it however we want. So for our purposes, we would like to add just an input and then an output because it's a fairly simple system. So this is a 16 channel and 24 volt DC input module. So I click it, as you can see, it highlights the rectangle, which shows that what slot I can attach it in to the CPU. So I'll attach this digital input to the slot number 2. I can just click, drag, and drop it. So now you can see it's inserted inside this. So next, I can also add a power system. As you can see, here I can edit at 0, but then we do not need a power supply for this project because it's already built in actually. And now I just want to pick a digital output. So I'll just drag and drop into number 3. So there's done. Now I have my CPU, my digital input channels, and my digital output channels. So now what I have to do is I click this rail, which selects everything here, and then I compile it. Okay, so now it is done compiling. So what I basically done here is I configure the hardware setups, which are the hardware modules that I needed for this project. So after I compile it, it basically creates like blocks for me that is available for me to code it with, like program blocks, something like that. So with that, I am able to code it later, which we will get into it soon. So that's this until this part. This is all about hardware. Okay, now click the program blocks at your project tree here. You click the main, you double click this, and this will be shown. This is your network, your branch. This is the first branch. However, but first we would like to create some new tags so that we are able to identify our devices. We can define our devices that we'll add soon. So first I'll add a new table, and then I'll just rename this to water pumping system. Okay. Now this is okay. I'll double click this. So now as you can see there, I'm able to add some devices. So the first thing we need to add is our pool low level system. That's right. So for water pump, we'll surely pump water from a pool to the tank. So this is our pool low level system. Okay, now this one is assigned to I0.0, which is our digital input card that we added before, and 0.0 is the first channel. So the next thing we need is also a tank low level system. So this one assigns to the I0.1, which is the other channel in the digital input card. Then we also need a tank high level system. And these are our three inputs. We need a pool low level system, and a tank low level system, and also a tank high level switch. Okay, now we would like to, these are our three switches, which is our input, and then now we will have our output, which is a motor pump. That's right, it will be our output. So now I want to change this to, so identifier Q with number 0. Right. So now you can see here it understands that this we identify it as our output, and these are our input. Okay, so now that it's done, we can proceed back to our main code block, and we would like to start adding our much needed devices. Okay, so now as you can see here, under my basic instruction, this is where we can find our devices or our operations. So under the big logic operation, we'll look for, so now we want to simulate a water pump. So at first we'll look for an SR unit to be our water pump. So this is a R flip flop, which we will use it to start and stop our motor. So why we choose an SR is because that we want the reset to be a priority, which we can clearly understand in the next simulation that we will do later. So now we will just assign this to be our, oops, sorry, no, it's not pool level, it is the motor pump. So now this is our, will represent our motor pumps. And next we would like to add a open contact and close contact point. So we would like to add a close contact, normally close contact at our 0 point, our set point, and then we'll identify it as our tank low level switch. Okay, so what does this mean? So this close contact will allow us to know that when it is false, it will set the input to 1 or true. And this way the pump will turn on because it is set. So this is where we need to, why we use a close from here, and then we'll add an open for our, for this point to the reset branch, and then we'll identify it as our high level tank switch. So next what we have to do is we have to add an open branch. Okay, so this is an open branch. So we added an open branch so that we can attach another close contact with this open branch, which will connect it to this, and this will be labeled as the low level switch. So as you can see here, this Q will be the output, which is the motor pump output, and this will be the tank low level switch, the high level switch, and this is the pull switch. Okay, so here we can see that we use the reset flip-flop control, which connects to the high level switch and also the pull level switch. This is because we want the reset to be a priority, because we do it like this so that this way it will turn off the electric motor or the pump when the water is when the pool is low level, or when the tank is high level, which we will show later and illustrate it in the simulation later on. Okay, so now I would like to talk about how to simulate it. So you're going to have the PLC sim. Now you just click start simulation. Okay, so you'll have this thing that will come up after loading. So you just load after when you press the start simulation, then you just load it. After that, for the module, just start module and finish. So after you've done that, you'll have to look at this, and then you'll click on this project view. Okay, now you'll look at this, and then you'll create a new project. So you can name it whatever you run on the pumping system. Just create it. Okay, so after you created a new project, you'll see there's some files here. So from this file, you can see there are a few things right here. So now, since we're trying to force an input into it, I'll use the sim table, and I'll click this sim table 1. Okay, I have already loaded, but before this, you have to press the load project text in order to load all the components into it so that you can control the input and output. And alright, so as you can see here, this is the part where I control whether the input is true or not. So now you can see that this will reflect whatever that is happening here. I'd like to say again, the green means that it's active, and then the blue dotted line means it's inactive. Okay, so now we assume that there is a pool, there is water in the pool, so it will turn active. So in that case, the motor will run because there is water, because it senses that the the tank low level switch and then the tank high level switch is empty. Means that the tank is empty, so it will start pumping the water from the pool into the tank. You can see this is green, means that there is output, and then the water is pumping into it. So you can see that so as it slowly fills up the tank, it will reach the low level, and then when it reaches the low level, this will become inactive. However, this is still green because the water will keep on pumping, because it will not affect the output. This is because the SR flip-flop will keep this motor running even though this is inactive. So it will keep running until it slowly reaches the high level switch. Then you can see here the motor stops. This is because, as you can see here, the high level switch will become active right here, and it will send a signal to reset it. So when it reset it, it will stop the pump, stop the motor, so that it will stop pumping water into the tank because it reaches the high level. Okay, so now as you can imagine, the tank, if you keep on consuming water, then the high level will slowly turn inactive. So it will slowly turn inactive, and then furthermore, more usage will turn the low level to inactive too. And then as soon as it detects that, this too becomes, it won't send a signal, and then the low level here will be set, and then you will start pumping water into the tank again. So this will keep going on until the pool level is inactive. So until the pool does not have any water, so the sensor will detect it as inactive. So and in this case, it will stop the pump, because as you can see here, the green, it directly has an input to the reset. So the pool level switch will turn off until when there is no water inside the pool. So as you can see here, this is why we use the SR flip-flop, because even it is empty, the reset input is still on. So when the reset input is still on, it will stop the water pump. So this will ensure that it won't be trying to keep pumping the water into the tank. So this is why it is built like this. So as you can see, if there's water in the pool, the motor will run again, and then it will just keep pumping water into the tank. So that's it for this simulation.